Okay, so part B says calculate the yield strain of each material. So strain is it's a dimensionless value, and it's worked out from this formula here. So this funny thing here, it's called epsilon, is equal to the change in length of the specimen divided by the original length of the specimen. Okay, so all you need to do is the original length of the specimen you'll have noted down, and I think it was something like 20 mil, so I'm saying 20 mil, but I might be slightly wrong. The original length of the specimen was 20 mil. So all you've got to do is work out the change in length. And what you'll notice, it asks for the yield strain. So what it's asking for is the amount of extension, the change in length of that particular material at the yield point. So if we go back to the graph, what you've got here, remember this yield point which we identified, the point at which it starts to curve and plastically deform. If you take a line directly down onto this axis, which is extension, what you'll notice is this particular material at the yield point had extended by 2 millimeters. So this is called the change in length, obviously, the amount of extension at the yield point. So that's our value here. So we've got the original length, and the change in length at the yield point is 2 millimeters. Obviously, if we go beyond the yield point, then the extension increases, but we're not worried about that. So all we need to do now is put in, there should be really a y there to say it's the yield strain. So the yield strain equals the change in length, which we said is 2 millimeters, divided by the original length, which is 20 millimeters. Now it doesn't matter because it's just a ratio basically. It doesn't matter about changing the units into meters. You can just leave them as they are, as long as the top and the bottom are in the same units. So if you've got millimeters on the top, millimeters on the bottom, it doesn't really matter. So we've got 0.1. It doesn't have any units because it's dimensionless, it's just a ratio. So that's called a yield strain.